Hello, it's Dr. Mears, and today we are going to work on percent error. The percent error formula calculates the error as a percentage of the measured quantity. Percent error equals absolute value, that means distance from zero, of V sub A minus V sub E divided by V sub E times 100%. What do these letters mean? Okay, V sub A is the approximate value, and V sub E is the exact value. So one's an approximation, this is what I think it might be, and one's the actual true measure. Let's do examples. Number one, a weight measures as 102 kilograms when the exact value is 100 kilograms. Find the percentage error of this approximation. What I like to do is I like to label. So this is the exact value, and they told us. So that's our V sub E. The other one is our V sub A. That's our approximate. Let's put them in the formula. Absolute value of our approximate 102, V sub A, minus our exact 100, all divided by our exact, which is 100. So these two numbers right here should be the same. So that could be a check. Times 100 equals. Now, if you want to do this whole process in the calculator, I need to let you know something. You have got to put parentheses around the top. We have got to subtract first before we can divide. So in your calculator, turn it on. You can either do this one of two ways. You can put it in, remembering the parentheses, divided by 100, and we get 0.02, or you could do this where you do 102 minus 100, press enter, and then you divide it by 100. We get the same answer, 0.02. If you want to do it in 2 steps, or you want to do it in 1 step where you remember the parentheses, we get the same answer. Okay, so we get 0.02, and it is positive. That's what these absolute values mean. The distance from 0 to 0.02 is 0.02. So this number, when it comes out of here, is always going to be positive. When we multiply that by 100, we get the percent of error that I made when I measured it. So I'm 2% off. That is my error. Percent error, okay? All right, let's try another one. Number 2, a weight measured 23 kilograms when the exact value is 27 kilograms. Find the percentage error of this approximation. So let's label. This is my V sub E. This is my V sub A. Let's put it in the formula. So V sub A, approximate, minus exact, divided by exact. These two numbers should be the same, times 100. Again, you could put this in the calculator all in one step, but remember that you need your parentheses. You're going to get in your calculator, I'm going to do it all in one step because I'm remembering my parentheses. I get negative 0.1481. I'm going to round this. I'm going to go to a negative 0.148. However, these absolute value symbols say that this number, when it comes out of here, it's now going to be positive. So this number will always be positive. So I'm going to put 0.148. So these absolute values mean that this is going to be positive. Times 100 equals 14.8% error. Ooh. That is much bigger than 2%. So something must be off with this scale here if I'm having a 14.8% error. That's a lot. Okay, let's get even a little bit more problem solving now. For this one, the temperature today in Chicago is 50 degrees Fahrenheit. Instead of using the standard conversion formula, here's my formula that I can take Fahrenheit and I can convert it to Celsius. Tommaso uses his grandmother's rule, which is easier, but only gives an approximate value. So Tommaso's grandmother says, subtract 32 from the value in Fahrenheit and multiply by 0.5. All right, so what do we have to do here? First, we're going to calculate the actual and approximate temperature in Celsius using the standard formula and then Tommaso's grandmother's rule. All right, so standard formula is this. So degrees Celsius equals 5/9. I'm going to put that in parentheses, everybody, because I'm going to put it in my calculator, and we need to put our fractions in parentheses. Okay, times the Fahrenheit, 50 minus 32. So degrees Celsius equals, and I could put that right in my calculator just like I see it, parentheses, 5 divided by 9, open my parentheses, 50 minus 32. And I'm going to get 10. So that's 10 degrees. That's 10 degrees. So that's what it is. I almost put Fahrenheit. It's not. This is what it is in Celsius. So we have 50 degrees in Fahrenheit, 10 degrees in Celsius. Okay, let's see what Tommaso's rule says. Tommaso says subtract 32 from the degrees in Fahrenheit, so 50 minus 32, and multiply by 0.5. So let's see what we get here. So we're going to do 50 minus 32 times 0.5. I put it in just like I wrote it. Oh, I get 9. Oh, a little off, but yeah, pretty close. Okay, so you see that we're about a degree off. 10 minus 9 is just a degree off. But part B, we have to calculate the percent error of the approximate value. Okay, so let's label these. This is our exact value. That's using the formula. This is Tommaso's grandmother's approximated value. Let's find what percent error we have. All right, so we have our approximate value minus our exact value divided by our exact value. Taking the absolute value, it's going to be positive, times 100 equals. Okay, doing this in the calculator, I want to do it in one step, so I'm going to put parentheses around the top. I get negative 0.1, but as it comes out, it's going to be positive because that's what the absolute value says. Times 100, and that's going to give us a 10% error. So we're off by a degree, but it's really 10% that we're off by. So you could look at it. So here we're off by 1 degree, okay? But in actuality, it's really a 10% error, and that's pretty big. So how you want to take it. Okay, so this has been percent error, some real world applications, and I hope it helped.